All right, so this is your introduction to Chapter 3. I keep saying that math people are lazy and that we have shortcuts for everything. So the limit process on the difference quotient can get pretty overwhelming. So I don't know if you noticed or not, but there was a T on this, by the way. But when we take a derivative using the limit process, what ends up popping up is going to be something like this. So if I have y equals 3x plus 4, okay, I'm going to take the derivative, which is y prime, and then if you will notice, your exponent is a 1. So what's going to happen is I'm going to drop my exponent out front and multiply. So 1 times 3 is 3. And then I'm going to drop my exponent by 1. So 1 minus 1 is 0. And then any number to the 0 power is 1. So that ends up simplifying to 3. So we can do this very, very rapidly to go through and figure out what our slope is. So another one would be something like y equals 5. Well, I want to take that derivative, okay? So the derivative, remember, I can always put x to the 0. So drop your exponent out front. 0 times 5 is 0. So you're done, okay? And that would be an x to the negative 1, but we don't care because 0 times anything is 0. Now come back up here. This was a line with a positive slope that slices through the y-axis at 4. Okay? What was your rate of change? Your rate of change was 3. Okay? This is a horizontal line that slices through the y-axis at 5. What's the slope of a horizontal line? It's 0. Okay? So what happens if I have something like y equals x squared plus 9? Okay? Well, take your derivative. Drop your exponent out front, so 2. Drop your exponent by 1, so 2 minus 1 is 1, which I'm too lazy to write. And then the derivative of any constant is going to go to 0. So this now becomes your formula for slope, for a tangent line, or the formula for instantaneous rate of change. So we've got a couple of different little rules here. This is going to be the derivative of any constant is 0. Now look up here for a second. 3 is a constant, but that's not his job right now. His job is a coefficient. So don't make him go to 0, otherwise everything is going to 0. Okay? So the derivative, if you don't have a variable written next to it with multiplication, then your derivative is 0. Otherwise, we're going to drop our exponent in front and multiply, and then drop our exponent by 1. So now we can rip through some of these problems, because they are going to all of a sudden get quite a lot easier instead of using the limit process. So I'm just going to go through some practice problems. So this is your intro as well as practice. So if I have f of x equals -2, and I say, would you please tell me what the derivative is? Okay, the derivative of any constant is 0. So you're done. Okay, that's it. So what about if I have something like f of x equals x to the 8th, and I say, please tell me what the derivative is? Okay, so in this case, we're going to drop our exponent out front. So 8x to the 8 minus 1 is 7. 8x to the 7th. Okay, what if I have f of x is x to the 6.9? Okay, I'm going to drop my exponent out front. So I'm going to go this way. So I get 6.9x, and then 6.9 minus 1 is 5.9. So that's your derivative. That's your formula for slope on the tangent line, and that is your formula for instantaneous rate of change. Okay, so let's do a couple other ones. We have, hang on, I can do this. All right. So I have f of x equals 9. Sorry, let's do -9, just to keep it fun. X to the 6th. So please tell me what the derivative is. So again, I have no idea if you're using the limit process on the difference quotient or if you're using shortcuts. So I would much rather that you use shortcuts and be a lazy math person. So take a derivative, drop your exponent out front. So negative 9 times 6 is a negative 54. X to the, drop your exponent by 1, and you get a 5. Okay, so let's do some with a formula that you may or may not know. This is the formula for the volume of a sphere. That's the formula for the volume of a sphere. So be careful, pi is not a variable. Pi is a symbol that stands for a constant. Okay, so pi is not your variable. In other words, he's going to come along for the ride. You only differentiate variables. So I'm going to drop my 3 out front. So I have 4/3 times 3, and then I'm going to drop my exponent by 1. Remember also that order doesn't matter in multiplication. So you could have put 4/3 pi 3r squared. Okay, but now that 3 and that 3 reduce, so you can clean that up to be a 4 pi r squared. Okay, so in this case, what you're finding out is the rate of change of the volume of a sphere as the radius changes. Okay, the volume of a sphere as the radius changes. So I've got a 15. So let's do h of x. 15x to the 1/6 power. And I want to take that thing's derivative. So I'm going to drop my 1/6 out front. So remember that's 15 over 1 times 1/6. Okay, so you multiply across the numerators, multiply across the denominators. X to the 1/6 minus 1. So 1/6 minus 6/6, okay, which is 1, is going to be a negative 5/6. Negative 5/6. Okay? Now, math people like symbols, but we cannot manipulate them. So we're going to figure out some ways to, some workarounds. So if I've got 7 times the square root of x, well, what am I supposed to do with that thing? Because this is a radical. This symbol is a radical. And it's not a number. I can't drop it out front. I can't drop it by 1. So I'm going to rewrite this with a rational exponent. So a rational exponent is going to allow us to do the math to it. So do we agree that this is an x, and since there's no power on it, it's to the first? Do we also agree I'm taking a square root? Okay, so there's an index there. It's a little 2, and since we take square roots most often, we're too lazy to write it. Okay, so I can rewrite this and say a 7x to the, well, it's to the first, but I'm taking a square root. Okay, so it's a 7x to the first, but I'm taking a square root. So I go back up to this one. This was an x to the first, but I was taking a 6th root. So I could have rewritten that as x to the first with a 6th root. Okay, so anyway, now I can take a derivative. So all I've done is rewrite. I have not done calculus. And now my derivative is going to be 7/2 x to the 1/2 minus 2/2 is a negative 1/2. Okay, and unless I need you to do something with it, it's actually easier to leave it like this. Okay, if we have to take a second derivative, in other words, if I have to do this again, I want it in this format. If I want to evaluate it for a specific x value, then we'll cover how to do that later. But for right now, we're just practicing. Actually, let's look at it now. All right, so we have f of w is going to equal 6 over the square root of w. Okay, so this brings us back to what a negative exponent is. So a negative exponent is going to tell you to flip-flop. I'm going to pause this problem for a second. If I give you an x to the negative 3, okay, this has nothing to do with this. Okay, I can write anything over 1. That negative exponent says switch locations in the fraction. So an x to the negative 3 is actually 1 over x to the positive 3. So that negative exponent in your numerator says whatever I'm attached to, put it in the other spot in the fraction. So this negative is on the x in the numerator. He actually belongs on the x in the denominator. Okay, so that's what that means. So go back to this one. If I wanted you to rewrite it, I could have said, well, I've got a 7 over a 2 next to an x to the negative 1/2. Really, that negative says, well, you're in the numerator. You can't see. Okay, you're in the numerator. I need you to be in the denominator. So you'll have a 7 times a 2 square root of x. That's how you would finish that out, because it's an x to the first, but I'm taking a square root. And the negative says put me in the opposite spot in the fraction that I'm sitting right now. All right, so go back here. That means I can rewrite this thing as, first of all, I'll have an f of w equals a 6 over w to the 1/2 power. Okay? Well, he's still in the wrong spot because I really don't want to deal with fractions unless I absolutely have to. So I need to bring him up top. So how do I bring him up top? Well, I can force it by changing the sign on the exponent. So that's actually going to be a 6 times a w to the negative 1/2. And now I've rewritten it in a fashion that I can take a derivative. So my derivative is going to be, drop your exponent out front. So 6 times a negative 1/2 is going to be a negative 3. W to the, well, what's negative 1/2? Minus 1. What's negative 1/2 minus 2/2? It's a negative 3/2. Okay, and then again, leave it like that, unless you are told otherwise. So I have got, let's do another couple. So I've got a 0.9 x to the negative 1.5. And I want to take this derivative. So he's already set up and ready for me to go. So I'm going to drop my exponent out front and multiply. So a negative 1.5 times 0.9 is going to give me a negative 1.35. X to the, and a negative 1.5, you can't see, a negative 1.5 minus 1 is going to be a negative 2.5. Okay? Let's try and grab another couple. All right, another rule with differentiation is you can go term by term. Everything I've done so far has been one term. So another rule is I can go term by term. So I've got a negative x to the third. I've got a positive 5x squared. And I've got a minus 5. Okay, so what is my derivative? So term by term means, well, do that one. That's going to give me a negative 3x squared. Do this one. That's going to give me a positive 10x, and then the derivative of any constant is 0. Okay, so another property is you can just go term by term. Okay, so let's look at this one. First of all, I'm in fraction world, and I'm not appreciating that at all. So let's see if we can get out of fraction world. Later, we're not going to be able to get out of fraction world. So I've got a 5x to the third. I got a minus 8x squared, and I got a plus 7. And all of that is over x. So we've been doing this with the difference quotient, where we've been just reducing every term. So I can rewrite this as f of x, reduce this one to a 5x squared. You are not taking a derivative. You are simply rewriting. Minus, this is going to be 8x to the first. And then this is not going to reduce, so he's a 7 over x. Okay, well now I can do it one more time. So I can say f of x equals 5x squared minus 8x plus 7x to the negative 1, because he has a first power, and I bring it up top by changing the sign on my exponent. Now I can take a derivative. So my derivative is going to be a 10x, oops, sorry, holy cow, 10x minus 8 minus, drop your 7, or drop your negative 1 to your 7, and then drop your exponent by 1. Okay, so that's how we're going to handle fractions for right now. And then we'll finish this video out on the next one.